Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? Today this is the 13th lecture of grade 10th. The chapter name is Chemical Equilibrium and the topic name is Important Applications of Equilibrium Constant. So equilibrium constant and the reaction quotient. In the previous lecture you have studied about the equilibrium constant, that what is it? Equilibrium constant is the ratio of the product of concentration of the products to the product of the concentration of the reactants at equilibrium state. Equilibrium constant is denoted by the Kc and it is equal to product of concentration of the products to the product of concentration of the reactants. At equilibrium state means the amount of reactant utilized must be equal to the amount of product formed. So this was the general equation that Kc is equal to product of the concentration of the products, that is C and D, to the product of concentration of the reactants, that is A and B. Here are some examples. For example, nitrogen react with hydrogen to form ammonia. While writing its Kc value, which will be equal to the concentration of ammonia, that is product, to the concentration of product of the reactants, that is nitrogen and hydrogen. Similarly, in case of methane and hydrogen, they form carbon monoxide with the release of hydrogen. So the carbon monoxide and hydrogen are the products to the concentration of product of the reactants, that is methane and hydrogen. Now the importance applications of equilibrium constant. First is direction of the reaction. We can determine the direction of reaction with the help of equilibrium constant expression, that is Kc is equal to concentration of product to the concentration of reactants. So the direction of chemical reaction at any particular time can be predicted by means of products by reactants ratio. The value of concentration of product to the concentration of reactant ratio leads to one of the following three possibilities. So for the direction, we will predict the product reactant ratio. There are basically three possibilities. First one is when the ratio of concentration of product to the concentration of reactant is less than Kc. Means now you have to compare Kc with the ratio of concentration of product to the concentration of reactant. So when the product by reactant ratio will be less than Kc, it means that the system is not at equilibrium and more products are required to reach the equilibrium. Therefore, the reaction will move in the forward direction until equilibrium is reached. Means when the Kc will be greater, the product reactant ratio is less. It means that now there is more probability and there is more requirement for the formation of the product. Now the complete product is not formed. So for the completion of the formation of product, the reaction will proceed in the forward direction. The second case is when the Kc value is less as compared to the product reactant ratio. What will happen then? Then there is more requirement for the formation of the reactants. Now we have to form the reactants from the products. It means that the reaction is in the reverse direction and it is not in equilibrium. The third case is equilibrium state. How? When Kc value will be equal to the concentration of product to the concentration of reactant ratio. So the Kc will be in, or the system will be in equilibrium. At any one point during the course of the reaction, that is non-equilibrium state. What does it mean? That when Kc value is less or Kc value is greater than the ratio of reactants products. It is possible to determine the concentration ratio of the products and the reactants using the same form as the equilibrium constant expression. This ratio is called the reaction quotient, that is ratio of concentration of products to the concentration of the reactants is called as reaction quotient, which is designated by the symbol Q. The computed values of Q are compared with Kc. Second importance is the extent of the chemical reaction, extent to which a reaction may proceed. can be determined with the help of equilibrium constant expression, means up to which extent a reaction can complete. For example, A plus B will give us C plus D. Now, writing its Kc value, which will be equal to the product of concentration of the reactants to the product of concentration of the product. Product of concentration of the product to the product of concentration of the reactant. The extent of the reaction depends upon the magnitude of Kc. So, Kc value may be small, Kc value may be large, or Kc value may be neither large nor small. When Q means ratio of concentration of product to the concentration of the reactant is less than Kc, the reaction will proceed in the forward direction. When Q value, that is ratio of concentration of the product to the concentration of the reactant, is greater than Kc, the reaction will proceed in the backward direction. When Q will be equal to Kc, the system will be at equilibrium. Third is the change of external conditions on the position of equilibrium. When a system reaches equilibrium, it will remain in the same state indefinitely if the conditions do not change. However, the equilibrium state of the system is disturbed if external conditions are changed. Means when you are doing a chemical reaction and you are changing the reaction conditions such as pressure, temperature, concentration of the reactants, it means that now the reaction conditions will change the chemical reaction and reactant will start converting into the product. Now the equilibrium state will be disturbed. The products alter the position of the equilibrium. Whenever the equilibrium is disturbed by changes in the external conditions, the system always tends to restore equilibrium. Means at the first, equilibrium will disturbed due to the reaction conditions, that is pressure, temperature and the concentration, but the product will restore the equilibrium condition of the system. This was all about today's topic. Thank you so much.